Hello friends, welcome back to our channel. Let's learn and grow together. In today's lecture, we are going to deal with the definition of refrigeration and the units which we are going to use for the measurement of refrigeration effect. Now, so let us start with the definition of refrigeration. Now, how we can define the refrigeration? Refrigeration is nothing but process of removing heat, or we can say process of removal of heat from a substance under controlled conditions. That is nothing but your refrigeration. Now, the device in which this effect we are getting, that device is called as a refrigerator. I'll repeat once again how we can define the refrigeration. It is nothing but process of removal of heat from a substance under controlled conditions, and the device in which we are getting such an effect, that device is known as a refrigerator. Now, as far as this refrigeration is concerned, there comes three terms, that is nothing but heat, and as heat comes, there comes sensible heat, as well as there comes latent heat. Now let us study one by one. Now how we can write regarding heat. Now heat is nothing but what? Simply energy which is in transient state. Now transient state means what? The energy which we cannot store for longer time, that is nothing but energy in transient state. This we can measure in different units, that may be kilojoule, joule, that may be calorie, that may be kilocalorie, and so on. Many more units are there for the measurement of the heat. Now how we can define this sensible heat? For that, let us take an example. Suppose I am having one metal, suppose this is our metal, and this metal is at 30 degrees Celsius. Now let us say that its melting point is equal to 100 degrees Celsius. For example, we are taking. So prior to phase change means, if I will provide heat to this substance which is at 30 degrees Celsius and it will be heated before 100 degrees Celsius, then the amount of heat supplied will be sensible heat, or in brief what we can say, the energy which is received prior to phase change, that is nothing but what? Sensible heat. Vice versa is also true. Means if I am cooling any of the object or substance, suppose once again take same example. Now instead of 30 degrees Celsius, this substance temperature is, let us say, 99 degrees Celsius. From that 99 degrees Celsius, we are going to cool down this substance up to its freezing point. Then the amount of heat which is consumed by this substance, this is nothing but what? Sensible heat. Now how we can define the latent heat? Now latent heat is nothing but what? The heat which is required for phase change to happen. Means if I want to have the phase change, then I must supply that latent heat. Now there are two types or two names to this latent heat, that may be latent heat of fusion, or that may be latent heat of vaporization. It means how we can define latent heat of fusion. Suppose if I am converting ice into liquid. Now in order to convert ice into liquid, here two phases are there. Ice is nothing but solid and this liquid is in liquid state. Now in order to have this phase change, how much quantity of heat is received or how much quantity of heat is gained, that is nothing but latent heat of fusion. Now let us take this example further. If I have to convert this liquid water into vapors, for this phase change also there is a requirement of some heat to be gained or some heat to be absorbed, and that heat is called as a latent heat of vaporization. If you take any pure substance which may be in solid condition, or that may be in a liquid condition, or that may be in gas condition, in order to have its phase change, some amount of heat is required, and that heat is called as a latent heat. That is, latent heat might be latent heat of fusion or latent heat of vaporization. Now you might be clear with the definition of refrigeration, followed by how we can define the heat, then sensible heat and latent heat. Now let us study how we can measure that refrigeration effect. Now for measurement of heat, we are having units as joule, kilojoule, then watt, kilowatt. Like that units are there for the measurement of the heat. That may be sensible heat, that may be latent heat. Now, in order to measure the refrigeration effect produced, there has to be some unit. Before that, let us define the unit of refrigeration. That unit is ton of refrigeration, briefly written as TR. Now, how we can define this unit of refrigeration, that is ton of refrigeration? It is nothing but refrigeration effect produced by uniform melting of 1000 kg of ice in 24 hours from and at 0 degrees Celsius. I will repeat once again. The 1 ton of refrigeration is defined as the refrigeration effect produced by uniform melting of 1 ton or 1000 kg of ice in 24 hours of time from and at 0 degrees Celsius. Now here what we are going to do, we are going to convert 1 ton of ice which is in solid state, and that we are going to convert into liquid water. Means here which heat comes into picture, sensible heat or latent heat? Here latent heat comes into picture, and that too again here two types of latent heats we have studied. Which were those? First one, that was latent heat of fusion, and second one, latent heat of vaporization. As far as this definition of ton of refrigeration is concerned, which latent heat comes into picture? That is latent heat of fusion, as here solid ice we are going to convert into liquid. Now let us calculate how much is the value of 1 ton of refrigeration. That is equal to, here we are going to have the melting of 1 ton or 1000 kgs of ice. Now how much is the latent heat of ice? The latent heat of ice is equal to 335 kilojoule per kg. Like that, how much kgs we are having? 1000. Means what I will get? 1000 multiplied by 335 kilojoule per kg, and this effect we are going to have at 0 degrees Celsius, but for how much time? 24 hours. Let us multiply it by 60 so that I will get the final value in terms of per minute. And here finally I am getting 232.6 kilojoule per minute. Means what I can say, 1 ton of refrigeration is equal to 232.6 kilojoule per minute. But for our simplification, what we are writing, 1 ton of refrigeration is nearly equal to 210 kilojoule per minute. Now let us convert that kilojoule per minute into kilojoule per second in order to convert this in terms of kilowatt. 210 divided by 60. This 60 for conversion of this minute into per second, as kilojoule per second will be kilowatt. Then finally what I will get? 1 ton of refrigeration is equal to 3.5 kilojoule per second, that is equal to 3.5 kilowatt. Means finally what I can say, 1 ton of refrigeration is equal to 210 kilojoule per minute, or it is equal to 3.5 kilowatt. This is nothing but definition of unit of refrigeration, that is 1 ton of refrigeration is equal to 210 kilojoule per minute, that is equal to 3.5 kilowatt. Up till now we have studied or we have learned the definition of refrigeration, then heat, sensible heat, latent heat, then latent heat of fusion, latent heat of vaporization. Then we have studied the unit of refrigeration also. But in order to measure the performance of this refrigeration system, we must know some parameters. And those parameters are nothing but the coefficient of performance of this refrigeration cycle. Now, this coefficient of performance is also called as, or it is also called as, energy performance ratio. Means what I can say, COP is coefficient of performance and EPR is nothing but what? Energy performance ratio. It is equal to what? Desired effect upon work input, or I can write it is nothing but refrigeration effect produced upon work input. Now let us define that coefficient of performance. Already while comparing heat engine, heat pump and refrigerator, we have studied that coefficient of performance, but let us revise. Now let us consider two temperature sources. Suppose this is TH and this is TL. Then if I have to transfer the heat from low temperature reservoir to high temperature reservoir, means here I can write TH is greater than TL, then TH is high temperature reservoir and TL is low temperature reservoir. The heat rejected by low temperature reservoir is QL and that of high temperature reservoir is QH. But naturally we cannot transfer heat from low temperature reservoir to high temperature reservoir, means I have to supply some amount of work. Let us say this as a W. Okay. Now, in order to calculate the value of this W, what I need to do? I need to apply the energy balance equation. Okay. And from that, what I will get? W is equal to QH minus QL. Okay. Same thing we are going to write in the formula of coefficient of performance or energy performance ratio. I will get refrigeration effect produced is nothing but what? QL divided by W, that is equal to QL divided by QH minus QL, as here we have written W is QH minus QL. Now let us say that we are not knowing the values of QH, QL. Okay, and instead of values of QH and QL, we are knowing the values of TH and TL. Then how we can modify this equation, as we are knowing that this QH and QL is nothing but what? Change in internal energies. Means what I can write? Q is equal to mCp into delta T. Let us modify this equation. What I will get? QL is mCp into TL divided by QH is nothing but what? mCp into TH minus mCp into TL. From this denominator, let us take this mCp common, and that mCp at denominator and mCp at numerator, it will get cancelled, and finally what I will get? COP, or coefficient of performance or energy performance ratio, is equal to TL divided by TH minus TL, or else what we can say, it is ratio of low temperature reservoir divided by difference in temperatures of high temperature reservoir and low temperature reservoir. This is nothing but the formula to calculate the value of coefficient of performance or energy performance ratio.